So in this video, we're going to take a look at the relationship between electrical current and electrical charge, and then we're going to extend that to look at energy that's consumed, and then we're going to make the connection there finally to cost. How do we calculate cost related to that? So in this example, we're going to be dealing with a automobile battery, and we're going to be charging it. And so when we charge it, we have a constant current flow to the battery of 2 amps. And we're going to look at this for a time frame of 5 hours. So 2 amps for 5 hours. So as you can imagine, while you're charging any battery, that the more you charge it, the voltage is going to change as it becomes charged. So they have an expression for us for the voltage across the terminals of the battery, which is given here, which is 11 plus a half T. And we need to take note that T is in hours. Okay, hours. So that's something we're going to have to deal with a little bit, because when we deal with our equations for that relates charge and current, it usually is in seconds. So anyway, let's take this information and look at what they're asking us and see how we do this. So for part A, they want us to find the number of coulombs, which that's charge, and then they want us to use that to determine the number of electrons which pass through our battery over the 5-hour period that we're dealing with. So as I mentioned before, we need our time to be expressed in seconds, not in hours. So up here at the top, I'm going to write down 5 hours. And we know that there are 3,600 seconds in 1 hour. That's 60 minutes times 60 seconds is 3,600. So if we do that, of course, the hours will cancel out and we're left with seconds. So 5 hours can be written as we multiply this out, 18,000 seconds. So we need to keep that in mind as we work these problems. So let's look at part A. So in part A, first thing they're asking us to determine is the charge in coulombs. So we can recall that our equation for charge, Q, is equal to the integral over some time of the current with respect to time. So in our case, our integral limits are going to be from 0 seconds to 18,000 seconds. That's 5 hours. Our current was told to be 2, which is a constant. So 2 amperes over the time, and this is in respect to T. So once we integrate this out, we will get 2T, and that'll be evaluated at 0 and 18,000. So this is just simple calculus now. So when we evaluate that, this now becomes 2 times 18,000. And when we multiply that, we'll have amp seconds. So when we multiply that out, that gives us 36,000 coulombs. So there's the answer to the first part of A. Now the second part of A, we have to recall how much charge an electron has. So if we look at that, if we take 36,000 coulombs, okay, we know that one electron has a charge, and this is just a constant you can look up, of 1.601 times 10 to the minus 19. So that's the charge in coulombs of one electron. So if we divide that out, punch that into our calculator, we should come up with 2.25 times 10 to the 23 electrons. So over that 5 hour span, charging our battery at a constant 2 amps. We have 36,000 coulombs of charge that passes through there, which equates to 2.25 times 10 to the 23 electrons. So that takes care of part A. So now let's look at part B. So in part B, they want us to calculate the joules, or energy, that's delivered to the battery over this time period. So we have an equation for that we can recall. So for part B, we know that our energy is going to, again, be the integral over some time. And it's going to be the power in terms of t, or time, integrated with respect to time. So in our case, we have to do a couple of things here. So first off, we do our limits of integration. And again, we've said it's from 0 to 18,000 seconds. Okay. And then we know that power is equal to, up here we know that power is equal to our current times our voltage, right? So remembering that, we know that our current was 2. And then we know that our voltage is given by this expression here. Now here's where we have to be careful, because remember, this expression is given to us in hours, but we're integrating with seconds. So we have to put a factor in there to accommodate this, to change it from seconds to hours, because we need it in hours now. So that being the case, we'll take the expression they gave us for volts, which would be 11 plus 1/2, and then we have to multiply that by 1 over 3600. So we're going backwards than what we did up here at the top. And that changes our seconds back to hours, and then that's times t. And then that's integrated with respect to t. Now we can distribute this 2 right here throughout the brackets. And so when we do that, our equation now becomes 0 to 18,000. 2 times 11 is 22. And then we'll say plus the 2 times 1/2 just cancels out. So it'll just be t over 3600. And this is all integrated with respect to t. So this is a much simpler integration. So we can perform that. So again, drop down here. And when we integrate that expression, we will get 22t plus 1/2 t squared over 3600. Again, this is just applying standard calculus rules of integration, and that's going to be evaluated from 0 to 18,000. So at 0, the whole expression is 0, so then we just need to evaluate it at 18,000. So we'll have 22 times 18,000 plus 1/2 times 18,000 squared divided by 3600. And so when we plug all the numbers in the calculator and calculate that out, we come up with 441,000 joules. So that is the energy that is delivered to our battery over that time period. So finally, in part C, they let us know that our electricity costs 10 cents per kilowatt hour. 10 cents per kilowatt hour. So in part C, we want to calculate the cost. So part C, our cost. So in this case, we're going to take the energy that we just calculated, 441,000, and that's joules. Okay, and we need to convert that to kilojoules. So we'll say times 10 to the minus 3 kilojoules over joules. So that's the same thing. So our joules cancel out. And then we need to multiply this then by 1 over 3,600. Again, getting it in the right format, and that's hours per second. Again, looking at our units. And then this is going to be times 10 cents per kilowatt hour. So just to rewrite that, that would be, let me write a little neater here. That would be 441,000 times 10 to the minus 3 times 1 over 3,600 times, if we're going to keep it in cents, then we'll just say times 10. And when we plug all that into the calculator, we should come up with 1.225 cents. So to charge our battery with 2 amps for 5 hours costs us just a little over a penny to do that.